Hey guys, welcome back to the channel. I have another Marine ECM. This time working in a 2000. Well, actually, I think it's 2005. Yeah, I can see that on the system information, which I'll show you in a second. 5.7 Volvo Penta EGC module. This is from Zac Williams in Tennessee. I'm moving his information away from here. Let me give him 1 second. All right, just covered his information. Okay, Zac Williams from Tennessee. He says, I have no injector poles. I have power at each injector, but no ground at any of them. I tell him, send it over so I can check it out, but that is very uncommon because these are specific drivers per each injector. So it's kind of hard that all of them are bad. It could be something else, but I said, send it over. So right now I'm running the computer. First thing that I want to check always is fiber reference. You can see that on Diacom. It will tell you the trim center bolts and the EGT voltage. Those are two separate fiber reference, and also show you the dual helm input, etc. So those are good. Computer is running. I can see every single injector pulse milliseconds in here and nice and crispy signals, and that is when you see the numbers complete in here, that means there is no glitches. It changes a little bit like in here and here, but that is normal. In idle, my idle speed right now is 628 RPMs. Engine operating hours 320 hours, so low hours on this computer. I am providing all the signals, so with these computers I can test it 100%. Injector coils, everything. So this setup is a 5.7, 5.0, and 5.7. They have an EST signal that goes to a module, and then that takes care of the firing of the coil and obviously to the distributor, because this is a 8-cylinder distributor type computers. So what we're looking for is for that EST signal in all the 8 injectors. So this is exactly what I have right now on the oscilloscope. I have the ESC signal and I have two. I pick up two of the injectors just to see if they're being pulled completely to ground, as I always do. And this is the importance of having an oscilloscope. You can see what's going on, what are you missing. I will go over to fault codes because he has a huge list of faults that he's going to have to address on the boat, but definitely not the problem is not in the computer. So Zach, your computer is working 100%. And this is also, I want to show this, how the voltage is, battery voltage being pulled to pretty much to ground completely. And then we have those leftover oscillations. That is a completely healthy driver. When I see that, it tells me the drivers are good. The signal for the EST, 0 to 5 volts, or 0 to 4 volts, I think, sorry. Let me put actually a signal in here. And reading his notes, which we will do in a second, he said that he has a spark, but no injectors. So he says, I have power of each injector, I have a spark, I have replaced cam crank and ignition coil. All right, so yes, he has replaced a lot of parts, but nothing has fixed. So this could be a harness. And this is why I don't see anything of that here. Obviously, it will be necessary to provide more data so I can help you better. So I'm going to turn this off completely. We're going to lose communication. We're going to see that in a second. It's actually behind because of I have the oscilloscope in here, but we can see a loss. So I'm going to turn this on. We're going to see the fuel pump prime in here. Okay, it did the priming. So we're back into communication. We can see that all the signals are now gone. Obviously, it's not running. And I'm going now to run the computer. So as soon as I press the start, it runs, fuel injectors, EST signal, all is there. So again, nothing wrong with the computer. Let me go over the fault codes that we have here. So I'm going to put this into a maximum size. So he has, and this is very important when you're analyzing data, like in this case, um, engine start since these fault codes happen 127. Okay, well, so we can disregard this one. The priority is not important. The air temperature sensor voltage high. So this was happening right away in his, and this is history, right? So uh, barometric pressure in the map low. So this is telling me fiber reference low. TPS sensor low. Okay, this is sounding like either a shortest sensor. So what I would recommend you to do is find one of these sensors. All of those sensors are going to be a 3-wire sensor. So you're going to have one wire is going to have a ground. So if you connect your multimeter, it's going to read 0. So you're going to connect one side with like a needle um, um, pin, like a, like I call those T pins. Those are the best. You can go behind. Let me get one of the, like, let's consider this the same thing. So this is uh, a, a specific lead for my testing, but if this is a needle like this, you can go on the back of that sensor, stick this carefully not to damage the insulation, right? And you go there and you connect your multimeter on that side to the sensor and the other side to battery ground. Do all your tests with battery ground, and then if you read 0, that is a ground. You touch the other sensor with ignition on, obviously, right? And you're gonna have on either of those, I mean, and one of those 3 wires has to read with ignition on 5 of reference perfectly. If you don't have that, let's say, and you don't know, because let's say, now you don't know which one is the one that is giving you the firewall reference, then you can start unplugging the sensors or call me and I can guide you to tell you the specific color. I don't think it's the case because you're getting a spark. So might be one or two, but you will see one with like the 3 volts and the other one with 0 or 2 volts. One is going to be the sensor signal. So you can difference that because yeah, we have also injector 2 short to ground, so make sure that one of your injectors is not shorted because that will take all, that would take a toll on the computer. It says loss of cam input. This is very important. If the computer doesn't have the cam sensor signal, it will not fire the injectors because that is the sequence for the injector. So make sure that you're wiring from the cam sensor signal to the computer is intact. And that sensor is a 5-volt reference sensor. So I will start right there because this is telling me that might be your case. And you already replaced, let me just see. Yeah, you said that you replaced the cam sensor signal, but that doesn't mean the harness, the wiring from the sensor to the computer is good. So you're going to have to check with a multimeter and a test light. So in this case, you're going to have to find the pinouts for the connector on the computer. You will unplug the computer, unplug the sensor, and check each first with continuity. And then the next thing you want to do is you're going to use a test light, one side, either side, the sensor or the computer side, whatever you want to do. You want to put a wire to ground. And then the other one, you're going to touch a test light to power, to battery positive, and it all has to light up. Like that, you know that the wires can carry load. Before you do the test light test, you want to use the continuity first, each pin to the computer, and then continuity each wire to ground or to power because they can be shorted to ground, shorted to power. Let's say you got a burn harness and one of those sensor wires is melted touching the ground, it's going to be shorted. And it will show you continuity because now you disconnected the computer and you disconnected the sensor. But it will also show you continuity to ground because it's shorted to a ground or to a power. Again, all right, so I hope that I can give you some light of what is happening with your computer, but again, or sorry, with your boat. But again, the computer is working flawlessly, 100%. I'm going to do a high RPM test. So let me put at least, that's the desired, that's not the one I want. So we're gonna put the RPM so we can see, I always do that from the distance how much RPM I'm getting. So I'm going to increase it to around 4,000 RPMs. And we're going to see how the changes the injection milliseconds. All right, so I'm in 4,000. I have to increase the map value. So let me increase it to around there. And we can see now that we got 9.8 milliseconds of injection. It's happening really rapidly. Obviously, we increase the RPMs, and we can see that if I go back now to this, you see that we got more activations of those injectors, and we can see how wide they are now. So if I go down to idle, so let me go back to idle. Again, 600 is what the desired idle is based on order signals or something. Try to explain and show and adjust at the same time. Let me bring the map to normal reading, which is around 12.6. That's what I use for my test. And remember, this is my values, my test. But we can see now that we only have two activations on the same screen that we were have like six before, and now they're less width. Same thing, we're in 4.7, 4.7 all across the board. So all is good with your computer. Zach, I will be contacting you shortly, collect the test fee, and send this your way as soon as possible. Talk to you later. And all you guys, don't forget to subscribe. See you next time. Bye bye.